IPv6 Multicast Routing Rendezvous Points. Let's begin. Our objective for you and I in this MicroNugget is simple. It's to take a look at the benefit and reason why we have a rendezvous point in an IPv6 multicast network. We should probably back up just a little bit and take a look at what the benefit is of multicast is in the first place. So let's imagine that we have 100 clients and those 100 clients all want to view a video stream. So we have a video server that's pumping out content, and if we use Unicast, where we're sending a copy to every single device, we could send out that same content 100 times to 100 different IP addresses and they would all get it. However, that's a huge waste of bandwidth to send the same content out 100 times. Instead, we could use multicast. Instead of sending out to individual unicast addresses, we simply pump the content out to some multicast group address, like the one right here. Now that content being sent out as a multicast destination, these devices down here can all tune in to that content, and as it's sent down the network to those devices, we only had to send one copy of the data and everybody had a chance to go ahead and look at it. So that's the benefit of IPv6 multicast routing. How exactly does it work? Well, we're going to use PIM. PIM stands for the Protocol Independent Multicast. And protocol independent means that we take our network as it is. IPv6 unicast routing is working, which is a fancy way of saying we have reachability, it's all functioning correctly, and we're going to overlay multicast on top of it. The protocol independent part means I don't care, says PIM. I don't care how you got the unicast routing working. You could use EIGRP or ISIS or OSPF or static routes for all I care. As long as the unicast routing is working, we're going to overlay the multicast on top of that already functioning network. So when PIM is enabled, R1 and R2 will become PIM neighbors, R2 and R3, R2 and R4, R3 and R4, and they'll all know about each other. Now the big challenge comes in if we have this content for this group being sent into the network, we don't just want to forward it blindly to everybody. So here's what we do. We identify who needs the traffic by having these clients request it. And they request a join to this group, which is a fancy way of saying, hey, Mr. R3, if you see this multicast group content, we would love to see it. That's a join, and it's done with something called MLD, the Multicast Listener Discovery Protocol, and the specific message type is called a report, as in they are reporting that they would love to join that multicast group. Now when R3 sees that, it says, oh guys, I hear you. I will go ahead and I will open up this interface. If I see that multicast content, I will go ahead and forward it out to you. Now the challenge is that R3 doesn't have a copy of that content yet. We're going to identify one device on our network as the rendezvous point. So let's say that's R2. And we tell the entire network that R2, based on R2's IP address, he is the rendezvous point. So R3, what he does is this. He says, well, what I'm going to do is I know the IP address of my rendezvous point. I'm going to issue a join request through PIM to say, hey, dear Mr. R4, please forward that multicast content to me if you see it. R4 gets that request and says, sure, I'll forward it to you. I don't have that content, but you know what I'm going to do? I'm going to issue a join request towards the rendezvous point. Then if the rendezvous point does have that content, for example, if the content is flowing to the rendezvous point can open up its gig 3.0 interface, flow it down to R4, who will flow it to R3, who will flow it to its clients. And that, my friends, is the purpose of a rendezvous point. It's a specific point in the network that all the devices can use to initiate the flow of the multicast traffic through the network. In this MicroNugget, we've taken a look at the concept of a rendezvous point to initialize the flow of traffic in a multicast network. For more information on IPv6, come and visit us in our IPv6 series over at CBT Nuggets. I hope this has been informative for you, and I'd like to thank you for viewing.